All right, Mr. Gatekeeper here. We've got pretty much a brand new Xforce. Let's see, XT800. It's Mr. Richard's amplifier, Mr. R. And from the looks at it, I'm just giving my best educated guess. I'm guessing this is probably one of the first, possibly one of the first PP100 2x8s they ever did. And two reasons why I say that. One reason is the way the stamping is on the PP100s. Maybe this was the first batch that Xforce ever got. And also just the way the tuning is done to the box too. We got 110 picofarad caps from collector to ground, 300s on the top of the transformers. I believe these right here are still 270s. Got 4 wraps over here on the input of the driver section. I'm gonna have to change that down to 3. And yeah, just, you know, it's just a educated guess. There's one or two reasons why I'm pretty sure why this box failed. One of the most evident reasons. Look at this right here, man. The way this cap is literally fell off. Kind of money. I noticed that one of them had fell off. I don't know if that was due to heat or what. I really don't know. And we've got one over here that's broke off. I literally went over here and moved it and noticed that the leg was broke off. All the other ones seem to be on good. That's something you always want to do if you're ever building something. You know, when you solder something, you want to test it, make sure that part is on there. You know what I'm saying? And it's not coming off. And I've done a few Xforces already where they've used these ceramic disc capacitors on top of the transformers. They lose their value pretty quickly once they heat up. I'm about the best guess. I've never actually spoke to Arlen personally to ask them, but I think it was during the shortage, when there was a shortage of metals. At one point in time, I remember when that was. Luckily, it didn't hit me because I wasn't building enough amplifiers to run out at the time myself. I had a pretty good supply, but I know a place like Xforce, man, they pushing them amps out. So I know they hit them, and I hit some other guys I know too, some other builders. But this honestly wasn't, just from my personal opinion, this wasn't the best solution. These particular caps right here, they do lose their value pretty quickly. And Mr. BBI actually made a very good video that I watched. Very good video demonstrating how something like a ceramic disc doesn't have a heat tolerance nowhere near like a silver dip mica or a metal clad mica capacitor. And what I like to call on the fly, meaning while it's being used, the value will begin to decrease as the capacitor heats up. Once it cools down, you'll see the value come back up. I've been talking about this for pretty much ever since I've been doing this. That's one of the first things I'd learned, how capacitors work. And that's why we use silver dip micas. They're the best, some of the best capacitors we can use that hold their value under high heat. Ceramic discs usually are not real good for that. Of course, if you get higher rating ceramic disc, higher voltage, higher current rating ceramic disc, it gets better. But it's just the way the capacitor is made, the internal dielectric of it and everything. It's just the way it's made. they don't do real well under high heat. There's nothing wrong with using them in places where you know it's not going to be pushed near its maximum capacity, because you got two different things you're dealing with when it comes to these amplifiers. You got voltage and you got current, and you got to think about those two things. So anyway, not to bore you, man, we're going to get in here, and I'm pretty much going to have to do a good bit. I quickly noticed that the wire used on these chokes are not Teflon. And the way that I quickly noticed that was, see, I didn't do that. I haven't even put an iron in here yet at all, so it looks like that was done when it was built. The soldering iron touched it just a little bit. And yeah, you know, the chokes right here, you know, it doesn't matter if those are Teflon or regular wire. You know, it really doesn't. But when it does matter is if somebody gets in here with a soldering iron and, you know, leans it on it or something and not know that they did it when somebody's working on it. And maybe you got a wire exposed now, and I mean, these things can move around, you know. Me personally, I know it's more expensive. I just like to use Teflon everywhere I possibly can use it. Now, I use Teflon in the whole box except for my power wires. But in all retrospect, you don't actually have to use Teflon for like these chokes back here, but it's just a preference. I like to use it myself. But just to make me feel better, I'm going to replace these chokes for you. I actually got some already wound up, actually. I'm gonna remove all these ceramic discs right here. We're gonna throw some metals on there for you. I hadn't quite figured out if I'm gonna leave these 110s right here. I mean, they'll work, but you know, it appears that that's another reason why I'm thinking this is one of the first PP100 boxes they did, because I see evidence of like these collector caps being changed. See that, you can tell they were over here. Maybe they had, I don't know, maybe they had something else and these worked a little better. You know, I don't know. I know there's a difference in the first batch of PP100s and the second batch of PP1. There were, as far as I know, 100% there were two different batches. Now I don't know if there was more than two, but 100% there were two different batches of PP100s. That's why it's not real good to mix and match them. If you want to be real technical, you know, it's not really good to mix and match them, especially if you have an idea they could be two different batches. I can tell these right here are a different batch than what they're using now. It's pretty evident. But, you know, I'm about to get in here and optimize the circuit for these HGs. These right here are 300s. We'll just see how it tunes. You know, that's what I'm about. Let's see what the box wants. You know what I'm saying? Let's see what the box wants. I'm about to break it up, you know, in each 4-pill section. I'm going to tune one of the 4-pill sections and see what it's going to want for the input and output loading capacitance. And I'll deal with this driver over here too. And he wants it staged. And we're also going to be throwing a wiMOTE back in here too, an internal wiMOTE. And we're going to be putting a variable on it as well. So, yeah. And I should have no reason to have to mess with the input and the output LC circuits. Or you can call them an L circuit if you want. It's shaped like an L. But they're really an LC circuit. You got a capacitor and an inductor. LC. And just in case if anybody's ever really wondered what this is and what this is, of course they're impedance matching networks. It's all about keeping everything at 50 ohms. This right here is having to combine two sections. Well, each of these sections at the feed point, the output feed point, you know, which this right here is the source at this point, and this is a load. The antenna is a load. Well, this is supposed to be at 50 ohms if it's loaded correctly, the loading capacitor, and this is too. So you got two 50 ohm feed points. Well, you can't just take two 50 ohm feed points and put them together. You know, technically it's going to be a 25 ohm feed point. That's where this comes into play. Take two 50 ohm feed points and keep them at 50 ohms. That's what it's all about. And hear people say, you know, keep it on frequency and this and that. Well, you know, if the impedance isn't correct, then it's not going to be on frequency. So it all kind of plays hand in hand, you know, but I more or less look at it as impedance more than, you know, primarily impedance matching more than, you know, tuning it on frequency, etc. These are wide-banded amplifiers here, but this right here does make it more narrow-banded. So I'm saying you got you a curve and all that. So we won't get into all that crap. A lot of y'all, that bores me. I just want to see the amplifier working, gatekeeper. Come on, man. You got to always talk all this techno crap. We'll be back. Alrighty, brother. I have I've got all the parts removed here. It needs to be removed. I want you to know every single transistor gain had dropped below 1, as in reading it from an atlas. So every single one's reading as a series diode network, except 2 of them with a gain of 2. One was a driver, and one was one of the final ones. So, pretty much all trash except them 2. Somebody wanted to use them as a driver or something. But anyway, I've got the stage done. Got the staging done. Got all the mini coax ran for the staging. I've got the power wire ran for the new relay added. Got your variable added that you wanted. Okay. Got the variable added. Good high quality 2-watt Russian variable I've been using for a little while now. Almost dang bulletproof. I hadn't had one, nobody blow one yet. Got your new switch installed for the 2-fill section. Since this switch right here was already on right here, the way it's going to be is this is going to be your 2-fill section right here. That's going to be your 12-pill section, okay? I mean 12-pill, your 8-pill section. So I still got to match up some metals, match up some 120s. Let me get all these parts put in a bag and get them out of the way. I like working on this small table. I could be working over here on these bigger tables, but I think I like this table because it's kind of lower down. I just kind of like that. But I could switch these input transformers out to 61, but we're going to leave them in there. They'll be fine. I got to get these HGs installed right here for you. About to be dropping them in here in just a bit. And get this thing sewed up. And one thing I forgot, man, I cannot believe I did not think about this when we were talking about the wiMOTE, the wireless remote. You now have a staged amplifier, meaning to have a remote, you're going to have a dual remote so you can control the 2-pill or the 8-pill stage. So we had worked in for a single remote. I don't know why I didn't think about that ahead of time. So I'm about to drop in a bigger wiMOTE so you can control both stages from your remote control. So we won't take that much more longer. I don't even think I have any dual remotes in stock right now. I got some quads. I might have to put a quad in. You'll just have 2 more channels you could use in the future if you wanted to. Alright, man, I just wanted to do a quick update real quick, man. I'm going to go ahead and get these transistors dropped in and get some caps installed, some metals, and get one of these 4-pill sections tuned out so I can see exactly which output loading and input loading cap they're going to need. I pretty much had to strip out the whole tune as in loading. The input and output LC circuits, they're fine. I checked them just a minute ago. This one's tuned absolutely perfect. The input is tuned perfect too. No reflect at all coming back. They're good to go. Alright, we'll be back. While I'm matching these metals here, I'm going to give you a prime example. Mr. BBI did a great video actually on this already, but as you see, I got this metal Clad capacitor, 1000 picofarad, 5%, hooked up. It's reading 1.019 nanofarad, which means it's 1019 picofarad. Okay. Torch. See, not much movement. Actually, it increased a little bit. See how quick it cools down and goes back down? Now check this out.
In the beginning of it, it would be very clear, and I could see what's going on. But then, for whatever reason,
these are some of those.
Either past experiences will come to memory or come to the forefront of an individual that I was having.
102p 3 kilovolts. You see 102, 10 with 2 more zeros. These are supposed to be 1000 picofarad caps. But these particular ones are reading at 1500, like the last box I worked on. See, 1488 picofarad, 1500 pretty much. Now I'm gonna leave the flame on it, or just close to it, the same amount of time I did with the metal, or even less time. I'm just going to turn it on real quick and turn it off. Just put a tad bit of heat on it. Look at that, just a tad bit of heat. I'm talking about just a half a second, and it dropped 300 picofarad. Just a half a second. Alright, I'm going to leave it on there now as long as I did on the metal. It dropped all the way down to 500 picofarad. Now that's me just heating up the outside of the capacitor. The heat that this capacitor generates upon usage is going to be internal outwards. I'm just heating it up on outside. But as you see, it slowly comes back up to the original picofarad. And this is a prime example why we don't use ceramic disc capacitors on our output transformers, because that is the top capacitor, gets the hottest in the box, other than the output loading capacitor, the main output loading capacitor on the LC circuit, or on the output combiner. And if you can think, if you're sitting here using a box and you're keying up long-winded, and the capacitance on the capacitor has dropped down, you know, to 500-600 picofarad, now the box is out of tune. Okay? And when the box is out of tune, it's going to introduce more heat, because there's reflect now. And when more heat comes, you know, it makes it easier for other components to heat up. You get more reflect, and that's when you get a catastrophic event of blowing transistors, etc. This is an exact reason why we use metals. And if you notice in some of my builds that I have done in the past and still do to this day, like for example this 8-pill right here, if you notice on this 8-pill, it's an all metal clad 8-pill. Got 120s right there, metals on the tops, metals on the input transformers, gonna be metals on the input tune. You know, all that's not needed, but it dang sure makes me feel better to know that I got the absolute best capacitors I possibly could have for these particular circuits. This thing's gonna rise up all the way to 1600 picofarad. But anyway, so yeah, those, I just kind of wanted to show that. I know Mr. BBI had made a video showing it, which was a really cool idea. I had been wanting to make a video showing this before and never got around to it, so that was really cool. So that just kind of simulates, you know, keying on these things. And that's the cool thing about these metals, man. They can handle the heat, and they also cool down quickly too with the fan blowing down on it. And the ceramic discs, they when they take a hit, they rise back up and their value slow. And also another thing, the way these capacitors work too is of going down, losing their value, rising up, losing their value, rising up. This is something I've said the whole time I've been in this hobby, time and time again on these videos. Back and forth like this, even if it's 5 picofarad, just back and forth over periods and periods and periods of time, the capacitors will lose their value for good, meaning they will slowly lose until you take a capacitor out. It's supposed to be 1000 picofarad capacitor, and it's reading 600. You know, it's damaged now. The capacitor is damaged. And I see this happen time and time again. That's why when you do see people use silver dip micas on the top of transformers, a lot of times they'll double up. They'll double up, putting 2 capacitors in parallel. What that does is that doubles the amperage of the capacitors, not the voltage. It doubles the amperage. To double the voltage, you had to put them in series. So, you know, at least, you know, people like take 2 500s and put it up there, because you're not going to be exceeding 500 volts on the output transformer of a 2-pill. So, you know, they're putting 2 of them, two DM19 silver dip micas in parallel to double the amperage capability handling of the capacitors. You know, you'll at least see people doing that. But anyway, I'm just ranting. Let me get back to it. We'll see you. Alrighty, brother, got you all done. Finally. Took a little bit more time than anticipated. Like I said, we had planned on putting a wiMOTE in, but you did change to a staged amplifier later on. You want to be able to turn your driver on and off and run each stage independently. So there was really no sense of putting a single wiMOTE in at that point, because you would only be able to turn one stage on and off. So I went ahead and I didn't have no dual wiMOTEs left, so I went ahead and put a quad wiMOTE in. So you got 2 more channels to use if you ever want to use them in the future for something. I don't know. If you ever put anything else in this box you want to control, and just get your quad remote control and program it to it. So A turns your driver on and off. Always remember, the first one right here is your driver, okay? By factory, this is where the factory switch was, your 8-pill switch. So B will be turning your 12 pill on and off. And I've got it to where it enables the VU lights right here only on the 8 pill. Reason why is because these are calibrated for the whole 2x8. So it really would have no use of having these enabled for the 2 pill, and there wasn't really no reason to have to run extra wires for it. So this right here will only be enabled if you have the 8 pill on or both on. And the next, one of the other issues that was not foreseen before, ahead of time, were these fans, these blue LED fans. Take a look at them. These are 0.78 amp fans. You know, these would be a good fan for like a 2 pill or a 4 pill or something like that maybe, but they just was not pushing hardly any air out of this box. So like I said, now one single fan that's in here now equals up to about four of these. Each of these fans are here, I got one laying over here actually. I got a custom 4 pill I'm going to be doing here soon. It's in a 2x8 case. I'm going to kind of cut these fans back a little bit. These are some NMB 0.748 amp fans. These bad boys are pretty good, man. Pretty good. So you've got like at least 4 to 6 times more air flowing through this thing. Alright. Since I do not have a regulated supply big enough to run the show you the 2 pill section and also run the 2x8 and the 8 pill section, I've got it hooked up to my regulated supply over here, my small regulated supply. I'm going to go ahead and show you the 2 pill section operating, and I'll just key up the 8 pill section for the fun of it. It ain't going to be doing much, and then what I'm going to do is I'm going to go ahead and hook it up to the unregulated supply over here, just do a quick key and let you see what it's doing. So you'll see that everything's ready to rock and roll, man. I did a lot more work on this thing than I anticipated having to do. Here's all the parts that I had to remove. And of course, you know, there's a complete transistor switch out in it. Alright. You know, these fans are a little noisy. What makes them a lot more noisy is all these individual holes right here. It makes it a little bit more noisy, sucking all the air through those holes. But you know, if it's too noisy for you, you can simply throw a resistor on each fan to knock it down a little bit, which I could show you how to do. If you need to do it, I could ship them to you. But you know, it's all to each their own. You know, you may be running this in the back of a mobile and it ain't gonna be no big deal to you. You know, if you're gonna be running it right next to you, literally, I could understand that. But you want to be able to handle as much airflow as you possibly can stand. Meaning, as loud as you possibly can stand, to have as much air flowing through these things to keep these heat sinks cool. It is very important. Heat is your #1 enemy. Alright. So we are looking at the 1000-watt slug. I'm just going to be driving it with the 4-watt radio at first. You're going to be seeing about 80 bird, about 300 watts, somewhere like that. So that's what you're going to be using to drive into the 8. You know, and I could hook up a hot radio after that and show you the 2 pill then. I may do that, I don't know, we'll see. You got a remote, just use remote. Alright. Variables all the way up. 1000-watt slug. Oh, a little bit over 80 bird. Here's your PEP. Doing the bottom scale. Oh, yeah, about 320, 330. Oh, yeah, this thing's talking right there about 300 though, ain't it? Just talking. Old gatekeeper letting the mop flop in his 2x stage 2x8, getting down. Alright. Just for the fun of it, the 8-pill just hitting it with a 4-watt radio. Oh, dang, boy. This thing's still getting there about 650 watts. Shoot. Man, this thing's gonna work out just fine. Alright. Of course, if you hit that with a hotter radio, which, you know, that's gonna be all on you, big brother. The 2-pill section. See, the one thing about it, when you're working with a staged amplifier, the driver section usually is not going to do the same amount as if it was just a 2-pill by itself. You know what I'm saying? Because you got extra coax that's going through and stuff like that, so there's a little bit of dB loss, insertion loss, as they say. And but if you hit this with the 8-watt, like my hot radio right now, my 8-watt radio, it's doing about 160 bird or so, you know, and it gets up there around 450 peak. All right, so let's go ahead and get this thing hooked up to the unregulated supply over here, and let's see what she's doing. Be right back. All right, like I said, I am on an unregulated supply. I don't have these fans regulated, so I just went ahead and unhooked them. You know, this box needs to be run on a regulated power supply. You know, they're HGs for one thing. But like I was saying, this box needs to be run on a regulated power supply. So I'm just going to do some quick keying here just to show you the output. It's doing a little bit over right around 500 a bird or so, just hitting it with the bench radio. Well, you know, it's got two 2879s driving 4, so you know it could take a little bit of drive. 1000-watt slug. I'm just going to show you the bird, and I'm going to jump over to the hot radio, and we'll take a look at the peak. It's doing, you know, roughly the same peak on both radios. Not that much of a difference. I just don't really want to stay keyed on this thing no longer than I really have to. I want to at least show you the bench radio first. You know, this is my bench radio. Modulation turned up to 100%. It does like maybe 18 watts peak, soaking wet, somewhere around there. 1000-watt slug. RMS. Oh, so it's right there about 500 bird or so. Let's give this thing some drive, because that's really what it wants, a little bit more drive. I'm not saying you gotta run it like that now. If you treat these things with care, these HGs will last you. You just can't abuse the hell out of them like you can Toshibas. These are the best thing that came out of China, bar none. But you cannot abuse them like you can a Toshiba, that's for sure. Gains will drop on them. Alrighty. Alright, so we're going to be hitting it with about 8 watts. And like I told you before, when you're running a stage, you do have a little bit of insertion loss. The RF has to come in. I'll point it out here more in a minute, but it's got to travel around this coax right here to the variable, out of the variable to here, down here, back through this coax to the relay, and from the relay through that this coax right here. Let's see, where is that coax? Oh, yeah, duh. Through this coax right here, this one that you see right here actually, and back to the LC circuit. So it's got a little bit more coax you've got to run when you're running a staged amplifier. Alrighty. 1000-watt slug still. Focus. Oh, it's about 800 bird, a little bit over 800 bird. Let me see what the voltage is. I gotta string my neck over here. I really don't want to stay on this. See what the voltage is dropping to. Oh, it's on 15.6 volts. That ain't that bad. Oh, about 850 bird. If I hit it with a 12-watt radio, it's doing over $1,000. Just 2 more bird make that big of a difference. Oh, I need to show the peak for all you peak lovers out there. Hold on a second, let me take this slug out. $2,500 watt slug. I like to show the peak for all them peak lovers. I don't personally look at peak much when I'm running my station. I may look at it here and there. We got the 2,500 watt slug hooked up now, so we are looking at the top section where you see the 10, that is 1,000 watts. Oh, it's a little bit over 1,500 or so. So if you hit it with a 12-watt radio, like I was saying before that, if you hit it with a 12-watt radio, it's doing about 1,100 bird and about 1,800 peak. And I honestly, I ain't gonna hit it with my D-Rail radio. I could, but I ain't gonna be running it like that. I ain't really no need in it, man. When it comes to new transistors like this, man, I don't want to beat up on them or nothing, man. I wanted to let you be able to do that if that's what you want to do. But so you know, there's a little bit more loss when you go with a stage box, but you know, not any type of loss that nobody's gonna notice on the other end. And now you can pick how you want to drive this booger. Like right now, you know, I can come over here, turn the 2-pill section off, hook up a driver, and actually, if you want to, for the fun of it, we can do that. Probably even get a little bit more out of it. Let me see if I can rearrange hooking this driver up real quick. I'm gonna press pause. Alright, so I got two 1446s hooked up to it. We'll see if we get anything more out of it. Really less, just for the fun of it. So we got an external driver hooked up now. Make sure you never leave that driver on if you do this, okay? So we got an external driver hooked up, 1,000-watt slug still. Oh, about 900 bird it looks like. I'm kind of looking at it from an angle. Yeah, I should have just left that 2,500-watt slug in. Give me 1 second, I'm sorry. Looks like it gained just a little bit more output. I'm sure the voltage is up just a bit more, so we're just going to peak watch just real quick here. A little bit more peak watch. This box right here is driving it with like 15 extra bird watts, about 30-40 extra watts PEP. So it's driving it just a tad bit harder. So there you go, man. Let me press pause and get everything unhooked, and I'll just go around everything that was done and all that good stuff. So give me 1 minute. Alrighty. Alright, I got this bad boy unhooked now, so I ain't got to worry about crossing no wires or anything while I'm in here pointing around. Let me grab me something to point with there. Good God, I think that'll work. Alright, man. I had to do quite a bit in here. I'll just kind of start wherever I see put. The wires that's feeding the relays and everything, they were not Teflon wire either. I figured that out pretty quickly when my soldering iron hit a little piece of it. So, for example, while putting on the input loading caps, tuning caps, whatever you want to call them, and stuff like that, I had to be extra careful not to let the iron touch it, which I was. So basically, I pretty much know what HGs are going to tune out to, but you know, I use 1.5" by 1/2 inch transformers by preference. I don't normally use 5/8 core, but the tune can fluctuate a little bit. You know, of course, you got a little bit of inductance difference in the two transformers. So I like to still fine tune whenever something like that happens. So basically, I took the 270s that was off right here on the inputs, and I took the 150 20%ers off the outputs, and I basically individually hooked this 4-pin section up right here and tuned it out. So, you know, I know exactly what this one's going to tune out to, because each section is, you know, virtually identical. So it tuned out just about where most of my 4-pins tune out to, so you tune out like around 143, 144 picofarads. So I just made 2 sets of caps put together to equal that, and the output tuned out a little lower than normal. I went ahead and put you some more beefier caps in. They're the same voltage as the caps that was in there. These can handle a little bit more current, a little bit more amperage. And these bad boys are $5 capacitors, man. You can get these from Tony for $5 a piece. They're not really cheap. I haven't found them yet out there in the world of the economic world. But I normally don't have to use them no more that much. I've got a little small stash of them. So anyway, so we got the input and the output loads all worked out. By the way, I am doing a celebration SIG here because I've spent a little bit of time on this box, man. A lot more than I anticipated. So as you remember, the chokes were not wrapped in Teflon. Just to make me feel better, I went ahead and I used 443 core that I had here, just to speed things up, and I wrapped them up for you and put that there. I always like to use 43 core on these chokes right here to ground, because 43 does have higher inductance. They are a higher permeability core, and that's what you're wanting right here is inductance. I ain't gonna try to go into a dang teaching lesson. I'm bad about that. I'm sorry. But anyway, so like I said, I went ahead and left the 43 core input transformers on. A lot of times I'll take them out and put 61 on there. Sometimes I even use them myself in certain situations. It is rumored, which I am a believer in this, it is rumored, a lot of people will not agree with this either, but it is rumored that when you... Alright, well anyway, sorry about that, it got it turned off from somebody messaging me. So anyway, just remember, when you use 43 core input transformer, since they're a lot higher in permeability, that it kind of attenuates some of the RF signal you're putting into it a little bit, and the amplifier won't do as much power. That's what's rumored, you know. And I've kind of seen it happen like that. And then sometimes that's a good thing, you know, kind of help keep the input a little bit more stable. You know, it ain't always about squeezing every dang, you know, wattage out of this box you possibly can squeeze. I would rather my box last and know that it's going to last and stay durable and stay stable than try to squeeze every bit of power out of it. But that's just, you know, one aspect of it. I just went ahead and let them in for you. And that would raise up the cost a bit too. I know you're trying to get this thing done right, but not having to spend all the extra money in the world to do it. So anyway, of course I removed the PP100s for you. I cleaned up the pill strip, sucked some solder off of it too. As you can see, it looks a lot more better. You know, when you get in these boxes and get out of them, in and out of them, which, you know, this is the first time this box has been into other than it being built. I still like to suck a little bit of solder off to just make it a lot more cleaner, and I went ahead and also cleaned it up with some acetone for you. I like to do that too, so I can look in here before I key it and make sure there's nothing touching, anything like that. There was some 300 picofarad caps right here. I left them on because the input tuned out virtually flat. So there's no reason to take them off and change them. And if I would have had an issue, you know, with me not being able to get the input down via the loading cap right here, then I would have had to change them. There was no reason to, so I didn't do it. And I went ahead and matched you 4 metal clad capacitors, which we've already talked about. Took the ceramic disc caps off, put these on. Went ahead and matched you 8 120 picofarad capacitors, which are right here from collector to ground, and put them back here where they go. I'm not really sure why they had them 110s right here from here to here, because I could see down in here where they had the capacitors down in here. So I don't really know what's up with that, because this was a new box. You said you bought this directly from Xforce, so I'm not too sure. Maybe they had to change some stuff around or something when they put those PP100s in here. You can only guess, you know, and it ain't no need in guessing. Let's see. You know, of course, I had to add a new switch over here for you for the 2-pill section. New LED. Run your wire and everything up there. And while I'm over here, here is your quad wiMOTE module. Okay. Got some good ferrite, 43 ferrite on there. Make sure no extra RF travels up the line and gets inside the module here. Another thing I went ahead and did, which is the first time well, this is the second time that I've done this. It's regulated. I kind of done that too because I knew I was going to be running on a unregulated supply while testing. And but you know, these things are voltage sensitive. Okay, just in case for some reason this is ran on higher voltage or something in the future, I don't want this blowing. So I just went ahead and put a regulator on there for you. Okay, so that's what's feeding the actual power for the module itself. Alright, let me see if I can't maneuver this box. Hold on one second. Kind of turn it around here. Sorry you left in the black there for a second. So here's your new relay for the 2-pill section. And like I said, if you want to know the flow of RF, the RF comes through this yellow wire. See, this right here is something I always wish my buddy Stickman would have showed in some of his videos back before I knew how to stage, you know, multiple years ago. But you know, it comes in right here. If this thing's not keyed, it's going to go through this. If this thing has no power, it's going to go through this jumper right here, back to this yellow wire over to the 8-pill relay. But if it is keyed, it's going to come here through this coax right here, over to the variable. One of them tough Russian variables. Which you may need to use this variable, because I noticed just with my bench radio over there, it had like a 200 watt dead key. On the back here it says 1 watt dead key max. So I don't know, I'll leave it up to you if you want to follow by those rules. So I've dropped the tuning pad right here, which is what I like to do sometimes. It makes it easier for me to put my trimmer down and make everything cleaner to me without having all the, if I have to use multiple capacitors like I did here. See, I'm a fine tuner. I really am. I haven't got out of that habit yet. Sometimes I get lucky and only have to use one capacitor, but when I come up to an odd capacitance like 137, I find 2 capacitors to make 137. I just don't put 135 or 140. I don't round up. It's an OCD habit, which is nothing wrong with having when you're dealing with tuning. So I like using what I call tuning pads. Of course, it goes through the variable right here down this white wire to the tuning pad. There's your input tune. There's your new 43 choke right there. Had to put a 330 right here, which tuned out perfect. I didn't have to go any higher. I've had to go as high as 500 at times on 61 core. But anyway, so here's your new driver, HGs. There's your new metal right there. Okay, so that's your driver section. Output loading cap in the back. Another thing I had to do is put your bypass tuning capacitor. With adding this relay right here, since you got 2 relays, it introduced a little bit of an impedance mismatch. And this right here is for if you were keying through the box barefoot, if the box was turned off. So this right here brings it back flat, back to a 50 ohm impedance. It's all about the capacitive reactance when you get into this type of stuff. But it put it flat about 45 puff or so. I'm gonna start getting in that habit, ain't I? Pico fair. I like saying Pico fair. So I think that's about it, brother. Without boring you anymore. Had to run new wire also from here back to the remote module over there. And so yeah, man, I had to do a little bit of work, dude. Get this bad boy where you wanted it, Of course, on your fans right here, there's your diode board. And basically what that diode board does is that allows you to turn the 2-pill on and turn the fans on without the power feeding back down this other wire and turning your 8-pill section on. So you gotta have diodes there to block it, so you can turn each section on individually and turn the fans on. A lot of guys, they'll have it to where the fans don't turn on for the 2-pill section, or and then just turn on with the 8. But you can do a little diode arrangement like that to where they'll both work. The fans will turn on with the 2-pill or the 8-pill, or both. So if you just turn the 8-pill on, it's not going to feed back down through this wire. So there you go, man. That does it, man. We'll get these I figured out too, man, these screws are not stainless steel. I thought they were. I can tell that they're not. They're number 6 screws. I roughed up the top here for you too, man. I didn't want that to have 3 wires coming down. I already had 2. So the case itself right here is the ground for the fans. So there's your 2 new fans, bud. It blows a lot better. A lot better. And I think I covered everything, man. If I left anything out, it was probably small. Well, yeah, I did leave something out. I think you remember me mentioning, I went ahead and put legs on each of the output transformers right here. See them? I went ahead and put legs on there just to be safe. Once I put the pills back down, it did lift the output transformers up. But this board right here, the clear coat has been scratched off this board. It makes the solder flow, let me tell you. It makes the solder flow. But there's no clear coat on this board. It's been scratched up actually pretty bad. Not too sure why that is, as you can see. But, you know, since it had been scratched up like that, this is bare copper now. I mean, you can just take a continuity meter lead and just barely just let it just rest on it, and it's going to go off. And if you have a clear coat on it, the way the boards normally come, you could let a continuity meter rest on it, and it's not going to make continuity. So that's one reason why I did go ahead and put these feet on here, these legs or whatever you want to call it, these stands, just in case if it did slowly move down, this right here is going to keep it lifted up from shorting out. So that is something you don't want to happen, bud. All it's got to do is just touch that board just a little bit, and poof, there goes some pills. Maybe even all of them if it's bad enough. Alright, man, like I said, the input and output LC circuits, input and output tune of the box were spot on, man. Arlen did a jam up job on that. I'm gonna give him credit on that, bud, because when I hooked these up and checked the input and the output tune on the LC circuits, I mean, they were freaking flat, son. Flat. No movement whatsoever. Just like the input tune is, I mean, the feed-through tune is on this. No movement. Perfect match. Alright. You got something like this you want done, give me a shout. I am backed up. I'm only taking selective things in right now when it comes to repairs. At this present moment, I'm not taking any builds on. We're trying to get these last couple builds finished so I can bring out this 50 volt LD MOS technology, which I should have done about 6, 7, 8 months ago. If I wasn't so backed up, I would have already done it. So I'm working around the clock trying to get these last couple things finished. If I can keep these cotton pickers from coming down here and whooping me. I'm just kidding. I'm trying to get these things finished so I can release that really cool technology, man. Real excited about it. All right, we good and going. Old gatekeeper said it. 73rds. Bye-bye.